Let's find the equation of a plane that contains three given points. The first thing we're really going to need to understand how to do is define a plane in 3D space. And there's multiple ways to do this, but a very efficient way to do this is if I wanted to communicate this plane to you, I would give you a point on the plane. So here's a random point on this plane, and then a vector. And this vector needs to be perpendicular to the plane. So the idea here is this vector pops directly off of the plane. And if you look at the base of the vector, it should be perpendicular kind of in all directions as it approaches the plane there. Now, this is enough information for me to communicate this plane, but this isn't unique information. I could have given you this point, and maybe I could have given you a different vector, say this vector here. Notably, these two vectors point in the same direction. In fact, they're going to be scalar multiples of each other, but they don't have to be the same length. In fact, they could also point in the opposite direction, because a scalar multiple of a vector could include a negative here. So if this is a third point, maybe this is my normal vector. It's still perpendicular to the plane though. In fact, it really doesn't matter how long this vector is, as long as it's not the zero vector. We need a non-zero vector that's perpendicular to the plane, and that will be enough for us to define a plane, and we can use that to form the equation of a plane. And here with our equation of the plane, we see that we have a, b, and c, which are the components of the normal vector, and the x naught, y naught, and z naught come from that point that you get to pick. Any point on the plane will do. So now let's go ahead and find the equation of the plane for these 3 points. We know for the equation of the plane, we're going to need a point on the plane and a normal vector. All three of these points are going to be on the plane, so we'll use one of them, no problem there. And then we need to find, what's left is we need to find the normal vector. We don't have much information here. We just have these 3 points. And how do I find a normal vector? I'm not really sure. Right now, all I can really do is find a vector that connects two of the points. So here's a vector, PQ, that starts at P and ends at Q. I can also find another vector. This is PR. This is a vector that starts at P and ends at R. And just to show, both of these vectors are going to lie on the plane. Since their starting point and their end point lies on the plane, this is the plane that we're trying to find here, both the vectors lie on the plane. And why that's important is there's a way to combine two vectors to get a perpendicular third vector from the original two. And we do that using the cross product. And when we use the cross product here, we'll see that this cross product will look like this red vector, and this red vector is going to be our normal vector. The red vector is perpendicular to both the blue and the green vector, i.e. it's perpendicular to the plane itself, which is what we were looking for. And so now that we have a normal vector, being the red vector, we can take that vector and any point, so you can use this point, you can use this point, it doesn't matter, and we can create the equation of our plane. And in fact, we'll use this point here just because it has convenient coordinates. And now we see that we can fully define our plane using this blue point and the cross product. And just as a reminder, there's nothing special about the magnitude of this cross product in this example. If we're trying to define the equation of a plane, you could multiply that cross product by any positive or negative scalar, and it would still be a sufficient equation for this plane. Make sure to like and subscribe and let me know what you want to learn next.